Hello, YouTubers. Today I'm going to talk to you about some of the most fundamental concepts when it comes to building industrial software. In previous videos, I talked about the high-level concept of building your APIs and brokers, services, and controllers, and how you can simplify your entire development process and abstract away any external dependencies by just focusing your business logic on the service layer and then making sure your brokers with the dependency injection, your brokers have their own knowledge about, communicating with an external resource and doing all that work. Um, Today I'm going to dive a little bit deeper into the services layer. Now, if you're building something a little bit above just adding, deleting, and updating and retrieving a student, you might need a little bit more logic to be involved in your services layer, more than just the primitive basic CRUD operations. So let me share my screen with you here and let's start talking about, let's start with a simple schooling system. Like in a simple schooling system, we talked about, you could have students storage broker, and your student storage broker, it could have a student service, and your student service has a student's controller, something like this. So your student controller, student service, and all that, and your controller is communicating with your service, and your service is communicating with your broker, and your broker is talking to whatever external resource that you have out there, let it be a database or SMS communication, text messaging, emails, or whatever the case may be. Now, this is a very simple primitive basic CRUD operations, right? It works so well, your logic stays very simple, and there is absolutely nothing wrong with that. But the more you build real life complex systems, you're going to start to realize that, there are cases where multiple entities might come into play when you're working with multiple entities. For instance, let's just start simple by saying, where do I put the logic where I want to say this user is or this student is no longer at the school? Is no longer at the school. That means you need to create to retrieve the current student object and update their status into that their account is deactivated with the school or that unregistered, and then you push that back to your database. Putting that kind of logic on the student service layer is not a good idea. Why is that? Because student service layer is only concerned with validating that the entity, regardless what the entity, like validating that the structure of that entity is intact before sending it to the database. It has absolutely no business knowing about activation, deactivation of a student account. It doesn't really care about enlisting or listing into a class. It doesn't care about that. That's a higher level logic that should go beyond that level. Every time you have to deal with, pulling an existing entity from the database and then modifying its content and then putting it back, that definitely means that you are doing a higher level of business logic operations than what your direct broker neighboring validation categorized service layer is doing. So what do we do? What if I want to go and say, deactivate student account? What you would want to do is to add another layer in here that's called student processing service. And the student processing service is basically concerned with higher level operations. These higher level operations are like, activate student, deactivate student. Let's say it could be literally anything as long as it's communicating directly with the broker neighboring service, which is the student service in here. And as long as it's not trying to do anything smart with other entities. It's not trying to do anything smart with other entities. So your processing service is for higher level business logic. All right, you got this part. Now, sometimes, then you're saying activate student account. Obviously, you will have a controller right here that would communicate with your student processing service. There is a caveat to that though. if you have your student's controller communicate with student processing service, you can't at any point in time do something like this to maintain your existing CRUD operations. These CRUD operations have to move forward to the student processing layer, so your student's controller could actually communicate at any point in time with one service. And it's important. You can't have your student's controller communicate with more than one service at a time, because if you do that, that means it's doing a little bit of business logic. It's called the aggregation logic, and we're going to come back to that in a little bit. But for the time being, that means you can't do that. That's wrong. What you're going to do, let me color that red. So if I color that, I could put that in red, apply that. This is wrong, right? What you really want to do is that you're still going to have to move all your CRUD operations to your processing service. And in addition to the CRUD operations that your processing service simply delegates down the stream, you are offering in the additional operations that you want to add to the student service, like activate, deactivate, all that kind of stuff. All right, you got this part. Now, there are cases where you want to, let's say you want to deactivate a student account and also, unenroll them, from all the classes they've been registered in, right? So that the student is unregistered, they're not in the school anymore, but you want to also deactivate all their enrollment in the classes that are currently active. How do you go about doing something like that? In this case here, we need another layer on top of processing, which is, I'm going to copy all of this. We need two different layers now. So let's say you have classes storage broker. And you have in here class service. And you have in here class processing service. I'm going to tell you exactly what each and every one of those is doing. So a class service is basically, its main job is basically just CRUD operations. You're adding a class, removing a class, doing all that kind of stuff. Great. But the processing service is when you go and say, this particular student in this class is not a part of this class anymore. This student in this class is not a part of this class anymore. How do you go about doing something like that? How do you go about doing something like that? What you want to do is that, like in here, unenrolled student, you want to add another layer of services that we call orchestrators. These are our orchestrator services. Now all my lines are red. Let me fix that. All right. So this is Orchestrator Service. And I'm going to tell you right now what this Orchestrator Service does. The Orchestrator Service basically goes and says, if this is the case, if you want to unenroll a student completely from all their classes and deactivate the registration in all available classes, you want in here, since the purpose in here is basically deactivating a student, then the name goes back to the student itself, right? So student orchestration service. And this student orchestration service will basically receive just a student ID. It's just a simple student ID. It'll send the student ID down to the processing service. The processing service will retrieve that ID from the database. And that ID from the database, it'll pull out the student, and then it will say, okay, for this student, flip their status into deactivated and send it back to the broker neighboring service to persist that in the database. But also on this layer, it's picking up the student ID, right? Now it's going in here and saying, hey, I want all the classes that this student is registered in, and then deactivate all of these classes and push that downstream to the classes, the storage, sorry, the broker neighboring service for classes. So you see how these three layers, come into play. You have the processing, you have the orchestration, and then you have the student service, right? So in that matter, that means that you could have multiple orchestrations that are happening across your application. And let me give you an example. Let's say you're deactivating a student, right? You're deactivating a student and you're unenrolling them from your from their classes. But at the same time, let's say there's another stream in here. Wait for it. So all of this is talking to the database. That doesn't look right. All right. So you have this guy in here, and these are communicating with each other, and obviously you have the controller at the very front like this to go and say, okay, all of this is done, and this is student controller, right? You're still pushing upwards all the operations all the way upstream in addition to this additional business logic that you're adding on top. The only difference is that you're just pushing it downstream. Obviously, you're doing your own layers of validation. A service should never rely on another service's validation logic. But while you're pushing that down the stream, you're basically saying, okay, I'm exposing this functionality, and I want this functionality to be in good shape. You're basically validating only the things that make sense to you. Only the things that make sense to you, right? For instance, let's say we're posting a student, right? That student is just a post. This student processing service has no business in its communications with validating whether that student is, has, for instance, a birth date that's from the 1970s or any of that stuff. Instead, it's basically saying if it's not null, if that student is not null, and if that student, does not have garbage data in it, so you're basically validating just the structural aspect of it, just go ahead and push that down the stream, and at the very bottom, the broker neighboring service will take care of making sure that this student does not already exist, that this student already knows, the responsibility here is that the student is with respect to the storage of where we have this in storage. It doesn't have any problems in addition to that structural validation we're talking about. Notice that every service only validates in its data the things that matters to it, right? For instance, the broker neighboring service only validates what matters to it from the perspective of that, okay, for me in here, what matters to me is that the entire entity has to be in good shape. The entire entity has to be in good shape. But in the student processing service, for instance, if I'm sending a student ID and I'm saying deactivate that student, then all I really care about is that this ID is not an invalid ID. Is not an invalid ID. Even though this guy might be doing the same thing, but it's doing the same thing for a completely different purpose, right? On the orchestration level, all that you're really doing is that you're going and saying, okay, I'm orchestrating a communication between students and classes so I can deactivate downstream. All I really care about at this layer, like let's say I'm sending an ID as well, I still need to make sure that that ID is not invalid. I need to make sure that this ID is is in good shape, and I can't basically deactivate classes like this before I validate that this student does exist. You want to make sure that this student actually does exist. In that case, you want to go and say, okay, send it downstream to my student service to tell me whether that student is in good shape or not. Whether that student is in good shape or not, or that student actually exists in the database or not. If it doesn't, then this service here will throw not found student exception, propagates all the way to the processing service, so student not found exception, and then all the way up here it'll be student not found exception, and the entire process will be terminated, right? The entire process will be terminated. Anyway, that's just a little aspect of what, I'm trying to show you. Let's just go a little bit further into our communication here, and let's talk a little bit about the the situation where you have multiple orchestrators, right? So multiple orchestrators. So I'm going to copy all of this in here like this. And let's go and say there are things that, let's say, just assume there's another stream of information that needs to happen. Let's say you want to deactivate a student account from, sport events. You want to activate a student account from library events and all that kind of stuff. How does that work? You're going to end up breaking at any point in time your orchestrators or your services for your orchestrators shall not make calls to more than two services at any point in time on top of your logging broker and your maybe date time broker, right? But in here, the case in here is a little bit different because you're basically saying this is here is a student class orchestration service, but you also will need in here student, let's say student activities, or let's say subscriptions orchestration service. Let's say there is all these different orchestration service. So that student activities orchestration service is basically it orchestrates the work on, whether like I want to completely unenlist a student from all the subscriptions, maybe library subscriptions, maybe, particular activity subscriptions. In this case, this guy will be doing a little bit of orchestration between the student service like this and the subscriptions. Let's say this is subscription processing service. It has deactivate subscription, and then you have in here subscription service, and then you have in here subscription storage broker. And obviously all of this communicates with the database like this, like this, like this, like this. All right. So what's the deal in here? The deal here is that this service in here communicates only with student processing. If I give this a different color, you'll be able to see, what I'm talking about. I'm going to give it a green color. So there's this communication here, and then there's this communication right here. So what's basically happening is that if I give this guy a red color, maybe it will be more clear, I'm assuming. So there's this guy, and then there's the communication with this guy. All right, so now you can see each one of these services only is doing two entities, aggregation and communication, at any point in time. It makes it so much easier for you to be able to test and validate what this service is trying to accomplish exactly. So let's say I'm basically deactivating the student orchestration for the student classes, but I'm also deactivating their subscriptions. In that case, you can't have your controller call these two like this and say unsubscribe student, right? Or deactivate student account. What you really want to do is that you want another layer of communication like this. And this layer in here is what we call student aggregator service. This guy here doesn't really do any business logic. All it's doing is that it's combining all the services together. So when the controller calls, it just calls the one controller, and it just sends it the it sends it the ID basically, right? So the how you're going down the right path is when you're saying student aggregator service. All it's doing is that it's receiving a student ID to deactivate all the accounts for that student. And then all that it's doing is that it's saying hand over to orchestration, student class orchestration, and student subscription orchestration service, and it will trickle that down the road all the way down to the storage. You see what I'm saying? You could go at any point in time and say, okay, you know, I want to add more services. Your aggregator is the only class that has the capacity to aggregate as many services as it wants, because it's not really doing any business logic. It validates the same contract and then it's sending it down the stream, right? Someone say, but what if I want to wait on one service, you know, to return a particular value so I can do the other thing with it? I would say that's an orchestration service, because it's doing a little bit of business logic around what it's really trying to accomplish. You know what I mean? So in addition, so the aggregator basically will just be the one point of contact between a student controller, and let's say your endpoint will be student slash student ID slash, you know, deactivate that student account, and this deactivation will take care of unenlisting the student from one class, marking their account as deactivated, and then going down the stream and saying, okay, all of their subscriptions are completely deactivated. Does that make sense? So it's just a little glimpse of a little bit in depth, just to show you the difference between, you have your validator classes, validator services, and then you have your processing services. Processing services still calls one method. The only difference is it does a little bit of on top of business logic that's already beyond validation, right? And then the last one in here, sorry, the one before the last is the orchestration service, and then the last one in here is aggregation service. When you name your methods or your classes in that particular sense, it makes it so much easier for you just by looking, just by simply looking at the name or the category of the service. Immediately you're going to start realizing, yeah, this is an aggregation service. It doesn't really have any business logic in it. Skip to the next level. Unless what I'm looking for is to see that I'm aggregating the right values, right? Then that's completely something different, right? When you're looking at the orchestration, you're wondering, orchestration what? Am I orchestrating student class orchestration service, or I'm orchestrating student subscriptions orchestration service? What am I orchestrating, right? You could even have Uber orchestrations, like you have multiple orchestrations, and you could have an orchestrator on top of these orchestrations. We call them epic orchestrator. Epic orchestrator, basically it basically calls multiple orchestration services to execute a certain model. And you know, if you have more than 3 or 4 epic orchestrations on top of each other, because you have to scale, then I would wonder how simple your business logic really is, and whether you need to revisit the communication between your services. So that's pretty much it for today. It's just a little glimpse of how you're breaking down your logic downstream all the way up to the controller, or whatever external communication you're actually dealing with when you're trying to relay that kind of, you know, responsibility down the stream. In the next session, I'm going to show you that in action. I'm going to show you the, you know, how do you write the code around that, how you test drive that, how you can do an acceptance test for that, and all these following concepts. If you have any questions, comments, or concerns, please drop a comment in the comment section, and do not forget to like and subscribe. Thank you for watching. I'll see you in the next video.